Everybody, my name is José Luis Troncoso from Tellus Mining, and I want to share this couple of slides where I am going to talk about autonomous haulage specifically, with focus in open pit operations. What is the agenda proposed? I'm going to give you a short overview of our company, then discuss a little bit about what is an autonomous haulage system, general context and an overview as well, main players, vendors, and a little bit of history, drivers of success, and lesson learned, showing you a case study where we work with two mature autonomous operations in different commodities, different parts of the world, and we are going to share some lessons and some opportunities as well that we have seen. About myself, a little bit. I am technical manager of Tellus Mining, focusing mine automation and innovation, and working at several projects from engineering to deployment of autonomous trucks in different parts of the world, having participated in Australia, some studies as well in South Africa, Chile, and Peru, mainly the last couple of years. About our company, we are a company that was born in Australia. The original founders of Tellus, they work for Rio Tinto, and they learn a lot about the first operational deployments of this technology. And we are technical advisors, mainly for mining companies. We don't sell technology. We fill the gap between the OEMs or the developers of technologies, different technologies, and the mining companies. Usually, we are working very close with both, helping to make these kind of projects success. We have participated with different projects, as I said before, different technologies. Main focus is autonomous trucks, but we have participated with autonomous drills, fleet management systems, collision avoidance, fatigue management, and other kind of technologies with customers in different parts of the world as well, and different commodities. Getting into the topic, what is an autonomous system? Because we need to talk about a system, not a truck. There is one important part that this is not focusing one of the vendors or one of the technologies, just a holistic view of this kind of system. And it's the same during the different OEMs or developers. We have some hardware components on board, usually for perception. The trucks need to be able to see the close environment to the inside the mine. Usually LiDAR, radars, lasers, and to see what is happening close to the truck. There are some components for perception, another for positioning. GPS, of course, they need to know where is located. It's a high precision GPS, of course, and connection, and some hardware to connect with the network, the communication network of the pit, and to communicate with the central to receive orders or location or some other important information to make the right site. Is, of course, the hardware on board. There is some software on board, of course. There is a supervisory system that is like similar to is part of the FMS of the fleet management system, but is a module able to take control of the equipment, take control of the brakes, acceleration, the tray during the damp part of the cycle, and focusing in that space. We have as well the central room, the central room where there is some specific roles that they are in charge of oversee the right functionality of every truck. So we have the global system, GPS, hardware on board, communication network, plus this software that is the supervisory system. A little bit of history. This is like the mature systems or technologies until now. These days we have these vendors, Caterpillar and Komatsu. They have been running for close to 10 years of technology in different commodities, different parts of the world, different cultures, and they are mature technologies. More than 500 trucks running worldwide until this year, 2020. But there is some new technologies coming. There are some emerging players. We can name ASI, Epiroc, Hitachi, Liebherr, Velas, Chinese technology as well. They are developing their own system, but they are a little bit green. Than they are not so mature as these two vendors. But in the next 3-5 years, we will see more competitive market in this space. Of course, that we will see more autonomous operations, definitely, different parts of the world. Most of these emerging players, they are now running a couple of commercial trials in mining operations, so they are just in the final stage to become a totally commercial system, open to deploy in other mine operation. Sorry. Just a main landscape, a little bit of history. I'm trying to be fast on this. The first autonomous trucks were deployed in Chile, in a copper mine called Gabriela Mistral in the Atacama Desert. That was the first commercial deployment. That was in 1998, more or less. Sorry, 2008, more or less. And after that, a couple of years, the technology moved to Australia, iron ore. Rio Tinto took the flag, and they started to deploy this in iron ore, different commodities with different operational complexity. Another kind of mining as well, and it was successful. They increased dramatically the amount of trucks deployed in the coming years. So now they have more than 3-5 operations running with autonomous trucks. Even they not just new trucks, even they start to retrofit their old fleet or current fleet in that they used to work in conventional mode, operated by people. After that, the deployment of start to grow in Australia, then start to move to Canada. Again, Canada, the oil sand industry, they start to deploy another payload, another kind of truck, bigger than when we talk about copper and iron ore. We talk about to 30 tons to 90 tons. That is the class of the trucks. When we moved to Canada, sorry, we start to talk about the 360 ton, the ultra class models, the 787s, the 980s, according to the needs of this kind of mining. So the projection of autonomous trucks in the next couple of years is that we are going to see more than 2,000 trucks deployed worldwide in different commodities, different operations, different parts of the world. And we can see as well another technologies maturing, not just these two vendors that I talked before. We are going to see ASI, Chinese technology, Russian technology. So this is going to become normal. About the business drivers, what can we see? First, it depends on the commodity. We have seen different experiences in different parts of the world, different commodity, and different reality as well of different countries. But first of all, safety. We ensure that we are going to reduce the exposure of people to collision events. We reduce this exposure. Of course, we reduce the number of people on site. There is a robust risk management process in the autonomous area. The trucks they have an active collision avoidance system. Active, it means that if they detect that a light vehicle is coming in the safety bubble, for example, it's going to stop automatically for the layers of protection that are considering this technology. Second one, effective utilization. There is an very important improvement of the effective hours of trucks hauling materials. Like, for example, a benchmark conventional operation, it's between 15, 16 hours, more or less, worldwide. If with autonomous trucks, we start to talk about 17 hours per day, 18 hours per day, even more than that in the benchmark operations. We don't have meal breaks, toilet breaks, or different kind of delays associated with a man operation. So that's a massive driver for the business case. So you have the possibility to move more tons with the same fleet, or move the same tons with less trucks. So you reduce the number of trucks on site, you reduce capex associated with when you need to renew your fleet, or if it's a greenfield, of course, you have less capex in terms of amount of trucks, because the autonomous trucks is a little bit more expensive than a conventional truck. So there is a trade-off between less trucks and the additional capex required. Cycle efficiency, there are less variability. They operate in a consistent manner. So finally, the cycle efficiency is better. You get better result. Maybe in terms of speed, it could be that maybe in some operation you have seen a reduction in maybe in some maximum speeds, but at the end the cycle is less variable, and finally the cycle times are better, are more consistent, and you get a more consistent operation. And finally, capex cost. They are a trade-off between the cost of the trucks and additional infrastructure you need to buy to install in all your other fleet, ancillary equipment, shovels, light vehicles, and some infrastructure. But at the end of the case, this is much better in the long term. In the long term, especially when you need to renew fleet, when you need to you have a long life of mine plan, so you can get that value. So you need time, you need trucks. So if it's bigger the amount of trucks, bigger is going to be the benefit. As I talked before, it's a more consistent operation, less complexity. These shift breaks are reduced. The operational delays during the changeover time, and when you finish one shift and start another one, or meal breaks, that is definitely much better. And in terms of OPEX, we have seen a reduction in increase in tire life. So you reduce your OPEX in terms of tires. You see better performance of the availability. So you tend to get more availability of the trucks because the truck is less exposed to operational damage made by people, and the maintenance, the life expectancy of the main components of the trucks increase their life. Usually, at least we have seen 5% in the main components. That are I have been talking about the good things. What about the risks of things to take into account? Technology is mature, more than 10 years running in different countries, different commodities. So the risky part of this is to make a good process, a change management process, to define that you need to change the way of operate from conventional mode to autonomous mine. You need to change all the entire process, not just the mine, just all the organization need to understand that there is an important change in this. As I talked before, you see the projection of the autonomous trucks, more than 2,000 in the next couple of years. So there is a risk of a lack of experts. The OEMs are challenged to provide trucks in different parts of the world. It's the same. If you see Africa asking wars, Chile trucks, Brazil, Peru, Canada, Australia, and there is a risk of take the right people to start this kind of ramp-up period and to help all the customers. Regulatory legislation, some countries, they don't have a clear legislation about autonomy, so maybe they can restrict some things. So this warning, just to talk about that. Functional safety, same thing, is how you elaborate and create standards to ensure that all the software meets some standards, and you are making sure they are doing what they need to do. Cybersecurity, of course, there are a couple of important breach in the cybersecurity in mining companies. There are a little bit of them quite famous in different parts of the world. So this is going to be a very important thing for an autonomous mine. This is something that Rio Tinto have realized a couple of years ago, and they create their own standards. Even the Australian Department of Mine, they create a functional safety standard to help mining companies to manage this. Exposure to low GPS coverage, this is for some parts of the world. The system depends on the GPS network. And these days we are so used to use GPS even in our phones, but it can happen. There are some situations, that it can block or can reduce the performance of the GPS network. So this is something that happened at the beginning of the technology. In Chile, we had quite important problems with the technology, because in this part of the world there is some special phenomena called ionic scintillation, that it happens once every 7 years, where there are some solar activity that impact on the GPS. Safety in terms of deployment, the main streams to make sure to make a successful deployment. Safety, guarantee that you are not going to create unsafety situations or conditions for people. Functionality, ensure that the truck is going to do what it needs to do, go to a shovel, transport the ore or the waste to the crusher, dump in the crusher, dump in the waste dump, and interact with ancillary equipment, with light vehicles, and be able to do that. That is not from one day to another. You need a ramp up, at least a couple of months, no less than 6-9 months, where you are not going to see the value. You are going to see a reduced speed. You are going to see a reduced interaction with other trucks. But you need to plan this. This is just a thing of plan, because after that, you are going to make sure that you are going to meet the KPIs compromise in the business case in terms of availability, effective utilization, cycle time, stability, and consistency. And of course, that cost. You need to keep all the cost compromise under control. So in that regard, the engineering phase needs to think in all the details to deploy this technology. About lesson learned, this is something that I would like to share with you, that it's an exercise that we did with 2 companies. Of course, that I'm not going to say the names of the companies, but these are 2 mature autonomous operations, and similar truck, similar payload, similar amount of trucks. And we did an exercise, a workshop. We worked like a week sharing experiences. One of them, it was the operational model. It's like how was the approach to start with the technology. For example, the vendor involvement, thinking like they deployed a strong team of a vendor expert to run and operate the technology, and the other company, they did the vendor participate, but no as strong as the other company. So this is one of the main definitions. So what we have seen in this, during the ramp up stage, in one of the companies was longer than the other, because of course of the vendor involvement. They participate, so the ramp up was shorter. But on the other side, after they end this ramp up period, the adaptation or to the site operational complexity was better in the other company, because they involve more internal people in in the deployment. So after that, they in the medium term, they get better results, how to adapt the technology to the site operation, because it's not just to plug the truck and start to work in autonomous mode. They need to, this ramp-up period need to adapt to the mine. And in terms of reliability, of course, that one company one, got initial reliability better for the system. They got a lot of expert involvement. The other one, lower reliability. In terms of flexibility, company one, as they had more vendor involvement, they had less flexibility due to contract obligation. There are some commercial side that is people or expert hours, some things that they need to make sure because of the contract. On the other side, more flexibility to adapt to, because the contract was less restrictive, and they could adapt this faster. In terms of knowledge capture, or how you upskill people or your personnel, and of course that company one, finally the most of the lesson learned were kept in the vendor. So the company was not so involved in the detail of the technical, in all the technical details of the technology. On the other side, they need to invest more in training, more time, duplicate some roles to learn from vendors, but at the end of the day, they got better results, and they kept the knowledge in the company. In terms of fleet performance, here there is something interesting. We compare some very technical mining performance of the fleet in terms of spotted loading, spotted dump, speed, loading time, dumping time, payload, operational delays, availability, tire life, and functional safety. And what can you see here? You see some reds, some greens. This is just the percentage. Of course, that this is not information that we could disclose, but we see that two mature companies with autonomous haulage, and we see different results. And we start to dig a little bit, and you see spotted load, spotted dump. This is more related to the truck, to the technology, because it's something that now is done automatically. In terms of speed, same thing, and the difference is 5 or less than 5%. They are like quite close. In terms of loading time, dumping time, you see big difference. You see 25%, 68%. Why? You see two autonomous operations, but it's autonomous operation, but don't forget that still they interact with people. Now the shovel operator and the dozer operator in the west dump and in the loading area, they are just the two people that are leading all the process of haulage in that cycle. So they're still depending on people. So the loading time depends on how mature is the shovel operator to allocate the spot for the trucks, how the dumping operator is able to allocate and the dumping area and the virtual dumping area as well, because they need to do some things in the system. So it still depends on people. So that is why we see some big difference in terms of payload. Now the payload depends 100% in the shovel operator. They are able to spot the trucks in the specific place where he needs to do it. So the operator, the people is more important than ever. In terms of operational delays, same thing. They are focused in terms of people. The delay of area close depends on the shovel operator. The out of service, yeah, that maybe could be some technical thing, not so direct with people. Wait on digger, wait on dump. That depends on people. That people now is more important. Now is just one person in the shovel in the loading area and one person in the dumping area. So that's something that we need to remember. This is something really important. Now people is more important than ever. We tend to think that now with autonomous trucks we are going to reduce people and be less dependent on people. It's the opposite. We have seen the opposite. Now we rely more and in less people. We rely on the shovel operator, those operators, the central controller, the guide on the control room. They are now more important than ever. We see operation difference in terms of availability. That is more not so directed to the technology. That is more of the maintenance practice and maintenance program. Tire lives, both declare extended life at least 20%. So that's a main driver. And in terms of functional safety, one of them, they are very focused on this. They were creating at that time their own standard to manage this. And the opposite side, the other company didn't see this as important as the other one. So final remarks. Just Domenica, this is just my last slide. Yeah, I see that you're worried. Yeah, I'm just running out of time. The technology is mature, more than 10 years in the market, so it should be rare if a technology, a deployment fails because of the technology. That is going to be a very rare case. So now but what is important, what is a big risk, is like the companies are not able to meet the KPIs compromised in terms of availability, effective utilization, and tire life, and be able to get the value of autonomy. So it's very important how the organization aligns with this, to embrace this technology, to think in a specific organizational structure. Of course, that training and upskilling your people is very important, and improve the maintenance and planning standard, because you need to maintain better, planning better. You need to the short-term plan change as well. And in some part of the world is very important, the community acceptance. We have seen some project. I have participated in some project where the reduce in the number of operators is very, very, very important, and even they put on risk their license to operate. So this is something important depending on the country. And yeah, that's it. Just to that is Domenica, just to be on time. Sorry if I extend my presentation a little bit.
Don't worry. Thank you for sharing. The case studies were actually pretty cool. And I see here that there's a question from Gabriel. How do you measure the performance of the autonomous KPI, since once you switch the autonomous mode, the conditions of mine usually has changed in the process? What considers a baseline to make the comparison?
Yeah, here is two autonomous operations. So it is not the baseline. It used to be a conventional operation, but in this case, we were comparing two mature operations. So no baseline, just KPI against KPIs. Similar number of trucks, payload, same class of trucks, different commodity maybe, but that was the exercise we did.
Perfect. Gui, I will be connecting you with Jose offline, so I will be sharing his contact information. We are actually over time, but here we have two very interesting questions. So I'm gonna quickly go through them. So hopefully those could be like straightforward answers.
Okay.
What are the standards you're referring to for functional safety?
Sorry, could you repeat?
What are the standards you're referring to for functional safety?
Yeah, the European International Standard. That is what I was talking about. I don't remember exactly, but it's in the International European Standard.
So the ISO 26226.
Sorry, I don't remember yeah, but I'm quite sure that is the number 6. I don't remember exactly, but it's the European one. That was like the base to start to create another mining standard. Now there are some mining standards, but Australia is leading this. It's at the forefront of the technology, and they are like pushing the boundaries and discovering the new potential risks issues.
Fantastic, thank you.
And looks perfect. Okay, so now moving to the last question. From a functional safety standpoint, why do you still need to divide autonomous trucks from manned vehicles, given the last decade's advancements in onboard collision detection and fleet management systems?
Yeah. I think that like an industry, I'm talking like the mining industry, we didn't see this until autonomy. Before, because maybe we rely that always we have a person on board to take the control. So we were not relying in the last control. It was a person. So I think that was the reason. Now we don't have that control, so we need to start to think that the software is taking the control of the machine. So we don't have that last layer of protection that it used to be a person.
Perfect. Thank you, Jose Luis, for today's presentation. If you don't mind, I can share your contact details here in the chat, as looks like there are a couple of people that would like to contact you directly.
Yeah, sure. And thanks, Domenica.